Welcome to Sheridan College's Introduction to Instrumentation. This lesson is a part of Module 3, Temperature Instrumentation, and will focus on thermocouples.
Let's take a look at what happens when we extend the thermocouple circuit.
Here is a thermocouple measuring a blast furnace or similar heat. The reference and measuring junctions are so close to the source that the voltage readings are being affected and damaging the meter. Clearly, the reference junction has to be moved. The solution is to extend the circuit to a place where a proper temperature differential can be created by the distance and a cooler location for the reference junction. Notice that the new wires are different than the original. These are called extension wires.
Okay, we have extended our thermocouple circuit to a different location, and we used different metal extension wires. If dissimilar metals and a difference in heat can cause a voltage, wouldn't this junction do so as well? The answer is yes. So we need to observe the law of intermediate metals, which tells us how to extend the circuit successfully.
The law of intermediate metals states that a third metal in a thermocouple circuit does not affect the voltage providing the temperature of the three metals at the point of the junction is the same. This means that more common conductor materials can be used. This has advantages such as cost and availability should the extension wires require replacement.
Let's break the law down and see what it's saying. We don't want to create any new unintended Seebeck voltages at the extension junctions. The first part says we must ensure that the temperature of the extension junctions is the same. This is accomplished by connecting the wires on an isothermic block. An isothermic block is made from a material that is thermally uniform. That is, all points of the block are exactly the same temperature. The terminal screws on the block themselves are made of the same metal as the thermocouple, so we don't create another thermocouple. Keep this in mind if you ever have to change a thermocouple. Always observe polarity to avoid disaster.
The second part mentions three metals. Since the measuring junction is made of two dissimilar metals, then the extension junction wires must be the same conductor metal. In our example, the three metals are iron, constant tan in the measuring junction, and copper used for the extension wires.